So this is module 4, and module 4 talks about displaying geospatial. So in this one, we're talking about displaying geospatial data. Basically, it is creation of maps, how to do cartography, what's the cartographic process is, and we're going to talk a little bit about map design, and then we're going to talk about critiquing the maps. So, in terms of key fact, what is a map? A map is the visual representation of a location or area. Okay? And you use a map really to give information to somebody else about an area. Okay? And who makes maps? Okay? And so, in terms of a person, usually cartography is the art and science of making maps, and a cartographer is someone who designs and prepares a map for distribution. And so it is a cartographer is someone who studies the philosophical and theoretical basis and rules for making maps. Okay, and so there are different kinds of maps. We have what's called reference maps, and we have called like a topographic map, which is a reference map, and a thematic map, which is a map that shows information on attributes. Okay, and today we will look at generating some thematic maps and that exercise. Okay, and then the other kind of maps is qualitative maps, which shows nominal data, shows distribution, and does not include numerical information. Quantitative maps is basically something like thematic maps, which gives you an indication of quantity of numbers. And so, for example, a thematic map may show population density, darker, more people, lighter, less people. And so then there's the other kinds of mediums for distribution. So a tangible map means that it is physically tangible, like paper or a plotted map. And then a virtual map is on the computer. Okay, so when you see it on the screen, that's a virtual map. Okay, and then the other kind of map is called mental map or mind map. So ideas, concepts. So in GIS, we don't normally deal with mental maps, so usually tangible or virtual. Okay, so cartographic process. Step 1. So there's about 5 steps in making a map. So the first step is to define the purpose and meaning of your map. So what are the user's requirements? What needs to be communicated? And what's the best way to communicate that data? Okay, and step 2 is to choose the map scale. So for example, is it going to be a 1 to 2,000 scale map, or 1 to 50,000, or 1 to 1 million scale map? How big? Now, this is an area where it's always confusing, okay? When you have a tangible map, a paper map has scale. A virtual map has no scale. Okay, when it's in your GIS, and you're looking at it on the screen, that map has no scale. It's a virtual map. Only when you print it out to a printer or plotter, that you plot it at a scale. A hard copy tangible map. In your virtual map in your computer, on the screen, when you look at it, it has no scale, but it has what I call accuracy and precision. So, for example, if you have a well point, okay, that well point could be within plus or minus 50 meters, 10 meters in your computer. So it has accuracy, but no scale. Okay, we'll cover that, try and cover that later on as well. So there's a distinction. Only paper maps, tangible maps have scale. Virtual or computer screen of the GIS shape files have no scale. They have coordinates but no scale. Choosing scale. So the ratio of map distance to Earth distance. So large scale maps. So these are just for fun. Large scale map is 1 to 0 to 1 to 600,000. Medium scale 1 to 600,000. 1 to 2 billion. Small maps may only over 1 to 2 million. Step 3 is formatting, printing, and economics of reproduction. So what kind of map, what type of map, how will the map be displayed, how much will it cost to create the map? It's the tangible map. So if you send a digital PDF map, it doesn't cost anything. Okay, step 4 is to abstract and generalize the data pattern or placement of the map. Step 4 is how do we take the real world information like roads, buildings, etc., forested areas, and how we're going to prepare that information and how we're going to put it on the map. If you have a 1 to 2,000 scale map, you may have a lot of information that you can put on the map. It'll be okay. You can put a lot of information. You can put buildings, you can put trees, you can put fences. But if you're going to create a map, let's say 1 to a million, you cannot have all that detailed information in the 1 to a million map. So the 1 to a million map has to have less information. And when I was working in Japan, for example, the Japanese even change symbology as they have different scales in the maps. So a railway line would have different annotation. If it is at 1 to 2,000 versus 1 to 10,000 versus 1 to million, it actually changes how they represent the line. And then in terms of step 4 classification is combining different things into groups and classes. Yeah, so this is just what I was saying about Japan. So in terms of classification is, if you had a river and you did the blue line, the thick line, and as you increase the scale, you would want to just change the color so it shows up better. And the other thing is, as your map scale goes to 1 to a million or bigger, then you simplify the map. So you remove the okay, and then same thing with symbolization. So again, you may use different symbols at different scales. So step 4 to summarize is to abstract and generalize. All the information that is meaningful should be included on the map. And then basically it will select and organize information to communicate what they want to the reader. Okay? And then depending on scale, you would reduce the amount of detail to create a simple visual image. Step 5 is to design the map layout. So the 12 elements that make up a map, called map body, which is where the map is. Neat line, which is the line around the map. Insets is really small map bodies that show greater detail. A scale bar, a legend, which is also legend, title, directional indicator, metadata, and additional. We will see examples of this, so don't wait. We'll show you all that. Metadata, source information, projections, and then sometimes they have graticules and labels, additional labels. Graticule is the intersection of the coordinate. In terms of scale, size, and shape, for example, Tennessee, the top map is Tennessee, which is very long and narrow. So you would plot that map in landscape mode because the area you want to cover is long and narrow. And then the other part, because we're doing paper plots, then you constrain to the size of the A0, A1, and so on. Okay, so now title of a map. Title of a map should be big in size. Focus attention to the purpose of the map. Should be brief and should typically include where, what, when. They omit is bigger in captions. Okay, so the map body. So this is the map body is the focus area of the map, contains beaches and foreland. So in that figure there, it's a state of Arkansas, and you can see that there's an inset where the United States and the state of Arkansas shown up inside the United States. So heat map. Right. And you can do the same thing in Mongolia or NIMAC. So you can show NIMAC, and you can show a map of Mongolia, or you can show NIMAC right out. Okay, this is what's called inset. Now you have a map of the United States, and you have in the box red the inset map of Arkansas. So this is what it is. Okay, so an inset map is a small ancillary map, which is a small supplemental map or additional map. Larger scale than the main map, shows more detail than the main map. Okay, and then there's what's called location map. Okay, location map on the right, lower right is the location map. It's a small and southern map, small scale than the map body, identifies the location of the main map body. Used when you're not familiar. Okay, so map scale. This is the first type of map scale is the graphic scale. So everybody's seen these scales on maps before. Really, the other two, the verbal scale is describing 1 inch equals 20 feet. It's the verbal scale. Okay, so there's 3 types of scale. One is a graphic, one is a verbal, like a text description, and the other one's a representative fraction scale. Okay, and then legend. Okay, so the different types of map legend. So map legend, you describe in the legend the main symbols, features of the map. Directional indicator. So this is the north arrow, for example, is a directional indicator. Shows the orientation of your map to the north. And if your map has a grid, then you may not need the directional indicator. So labels, these are labels for information on the map. It allows the reader to gain information, like for example, you may have a label for a railway station location or a label for a hotel. These are labels on the map. Okay, metadata. Typically, I have found that a lot of cartographers miss this part, and this is probably the most important part of a map, is the metadata. So part of what I consider metadata is, for example, the source, who created the original data, what projection the map is made from, is kind of really important metadata. So for example, if we had a map of Mongolia and it was pseudo-Mercator, it would be different shape than if the map of Mongolia was done with UTM zone 47, for example. Now this was especially more critical in the old days, like 20 years ago, when a lot of digital information was digitized from hard copy maps. And if these maps had no metadata, the people that digitized them didn't know what the shape came from, whether it's pseudo-Mercator, WGS 84, Gauss-Kruger, or whatever it is. And when they put it into GIS, it did not fit because of the projection and missing metadata. So every good map will have metadata, including your projection. Okay, so graticule. It's hard to describe graticules. Graticules is basically lines describing the geographic coordinates. So you will show a map, you could show a map with a flat projection. It shows the lat-long grid, okay, and it will be curved. So those are called graticules, okay? You'll see maps. If you have topographic maps from Mongolia, military maps, they have these little crosses for the lat-long intersections. And we used to use those for registration, for geo-registration when we digitize topographic maps. So neat line. So a neat line is just the boundary around the map you want to display. And then additional text and objects, so other things that you want to put in. Map elements and best practices. Place map elements so that they're positioned and sized in accordance with their importance. Okay, they reduce white space, so you don't want to put all the important stuff on one side. You try to put it in the middle. So we can look at an example of this. So these are the points there, like the title, directional indicator, metadata, scale bars, legend, map features, map projection, and neat line. Okay, so those are items that go into a map. Okay, so here's an example of a map. All right, so the title is population density. This is the map we want to present. This is the legend. These are the scale bars. And there's the directional arrow. And this is some metadata. So those are all the pieces of a map. We'll criticize this map. Let's critique this map. So the critique here, for example, is that no neat line. There's no boundary. So you're showing part of Alaska here. So this is kind of information that maybe is irrelevant to this. Maybe it shouldn't be there, this part. I think they don't like this heading. This legend bar here, it says these decimals, maybe they don't need decimals. And then maybe you should not have Canada and Mexico background, okay? An ocean background is not needed. Okay, and so decimal degrees, you never show decimal degrees as a scale bar because decimal degrees change as you go north and south, okay? It actually shrinks. It's not a scale. It's not a fixed scale. You cannot use decimal degrees. There is no such thing. 1 square degree at the equator is different in area than 1 square degree in Mongolia. So you can't use it as a scale. Okay? This is big X. Data source, not descriptive enough. Bad map example. So in this course here, this person probably failed cartography because the teacher didn't like this map very much. This is a modified map. It says good map example. It has a different projection. Did you notice that the projection has changed? They say that the title is more descriptive, population density based on the year 2007. Contiguous United States of America. So just means that the part of the United States that is joined together does not include Alaska and Hawaii. So here his legend now says persons per square mile, and his scale bar now has miles and kilometers, not degrees. Okay, and he's rounded off the scale bars. So you're going to watch the scale bars should be, like 500, 100, those kind of numbers. And then I can't read that, but anyways, he says that's more descriptive. That's good, according to the teacher. Okay. All right, so this is considered a good map. So you can see the difference in terms of cartography. Okay. Personally, I prefer the north arrow to the right, but anyway, that's whatever we feel. Yeah.